Explore a fluid flow outcome. In this video, we'll explore generative outcomes, create a 3D design, and we'll review a 3D design. In Fusion 360, we want to carry on with our generative faucet design. This has a generative study that's already run and solved, so I'm going to head into Explore. With generative fluid, we were only going to see one version of an outcome, and this is because we don't have multiple materials or multiple manufacturing methods. So let's take a look at the one outcome we have and explore the variations that were created based on our original design. When we take a look at some of the options we have, we can show our starting shape. And if we view this from the left, we can see that our starting shape is having the generative build inside of that volume. So if we want to explore more areas or give it more flexibility, we can always increase the size of that starting shape or maybe even exclude it completely. Unlike a structural generative design, fluid flow really benefits from having that starting shape as there is a lot of room for it to try to explore. So whenever you can, make sure that you do include that starting shape for a generative fluid. Also note that we did have some areas where we needed to constrain the build. We wanted to make sure that we avoided this large cylinder and we used the starting shape to ensure that we were going up and around. We also had some constraints for going through the mounting plate on a sink and for the start and the end. If we take a look at our preserved geometry, we basically had the inlets and the outlets, and those were to define the fluid inlets and the pressure outlet. When we take a look at our display options, we can see a pressure view, which shows the area of high pressure, and then of course we're going to 0 psi or no pressure at the outlet. That's how we defined the study. We can also take a look at the flow lines. The flow lines are give us a good indication of the magnitude of velocity. Now, if we rotate this design around, we can see that we have the highest velocity just before the two inlets merge. Let's go ahead and rotate this around to a front view, and we'll pan up slightly. We can see here that the fluid flow increases in velocity right around this area, and then it tapers back into the area where it's going to merge. One thing that you'll note if we take a look at the original starting shape, the size of the tubing that is used for this outcome is much smaller than we originally had. So this tells us instead of using potentially a 3/4 pipe, we could use a 1/2 inch pipe. If we move our way up, again, you can see that the volume is much less. And if we rotate around to a left or a right view, one of the other things we'll note is that in the exit of this, you can see that we're flaring out just slightly. One of the reasons that we are flaring out here and the fact that the flow traces don't connect to our preserved geometry is because we selected an incorrect face when setting up our outlet pressure. So this is a case where we would really want to make sure we select that outside face of our preserved geometry to define that outlet pressure. So we're keeping the size of the tubing relatively small, and then we flare out just at the end. If we want to turn this design into a 3D model, we have two options. We can do this from the design outcome, or we can do this from a mesh. Either option will be fine. It really depends on what your goal is downstream. If you plan on working with this design as a T-spline body, then we want to use the design from outcome. If you're going to simply create a 3D print or you want to use mesh manipulation, you can turn it into a 3D mesh. Once we start this process, we need to wait for the outcome to be generated and then we can review it in Fusion 360. Now that a design is ready, we can simply click here to continue and open the design in Fusion 360. Now that we have the design open, there are a few things that we need to take a look at. We need to first identify what we have gotten from our generative study. When we take a look at the timeline, we have our preserves, we have our obstacles, we have a T-spline organic feature, we have a boundary fill that turns it into a solid body, and then we have this combine, which goes through and removes any obstacle overlaps. If we want to make adjustments to the T-spline body, we can do that by coming back into this organic feature and making edits. You can see here that we've got a pretty nice result in terms of the mesh density, and if we want to make any adjustments, for example, if we want to slim or smooth any areas out, we can always go in, make selections, and use tools such as Smooth, And we can use the smooth slider to try to smooth out these areas if needed, or we can use things like cylindrify to try to turn them more into a standard type cylinder. For this example, we're not going to make any changes to that, but we should make sure that we understand that what we're getting out of generative design is going to be a surface of the internal fluid volume. So if we want to turn this into a solid body that has that extra thickness, we can use tools like modify and thicken, select our T-spline, and then we can move it out, in this case, 0.125 inches. This is going to allow us to thicken that surface normal to the current selection, and we're going to allow it to unfreeze those edges. When we unfreeze those edges, we might potentially have a problem when we go into boundary fill. So if we take a look at what we have, you can see that we've automatically created a solid body here. So if we finish this freeform, we take a look at the results and we scroll back before that boundary fill, let's go ahead and hide all of the bodies with the exception of organic. We'll select all, right click, and show hide. Now you can see here that we actually have a solid body and we can carry on creating the interface between this and other piping in the design. Now we've taken that generative design and we've used it to create the internal volume, and that internal volume exactly mimics the minimum pressure drop that we need in our system. What we want to do from here is make sure that we save it. And if you did not solve your own study, you can go ahead and upload the supply design generative outcome.f3d. If you wish to manipulate the generative outcome.f3d design, you can go ahead and modify the organic feature and make adjustments, but do note that with the addition of that thicken, when you use the T-spline tools, you will actually have individual control over the inside and the outside faces. For example, if we took this outside edge by double clicking, used modify, and we scaled it out, that's only going to scale the outside and it's not going to modify the internal fluid volume. So this will allow you to make adjustments and edits to the shape, and that will allow you to keep that internal fluid path the same. At this point, I'm going to go ahead and save this design and move on, but you can carry on making manipulations and changes to the design as you wish.